Hi, everybody. It's great to be here. I've been working in artificial intelligence for a long time. You know, you could say I'm an AI hipster. I was doing it before it was cool. And just proof that if you work at something for 40 years, it can become an overnight sensation. So it's an exciting time for AI, and I think it's an exciting time for education. But I want to start by going back a few years. And here we see a great model of education. So if you got to sit down and talk with Socrates, you would get a good education. And he would lead you to know what you needed to know. But then we started to automate the process. And the first part of automation was the invention of the university in the 14th century. University of Bologna was the very first university. And now instead of just having one-on-one, you could have 1-on-30. So it made it much more efficient. And I gotta say, we haven't done that much since then. Look at what's happening in the 14th century. We got the teacher up here, we got the textbook, and we got the guy in the back who's sleeping. Right? So not much has changed in the intervening 600 years. But maybe there's an opportunity for us to do better. Back in 2009, my colleagues and I wrote this paper called The Unreasonable Effectiveness of Data, saying, you know, we think this era of big data is coming, and there's a lot of applications you can do with it. And one of the applications we thought we could do is, let's take some data from students as they're learning and see if we can help them with their learning efforts. And 4 of us helped start 2 education companies, and these 4 people here, you may recognize some of them, they're all in machine learning and AI. So we all kind of simultaneously felt that there was data out there that we could use to make education better. And Sebastian and I did this online course in 2011. As I look back, I kind of cringe at the graphics there, a little bit hokey, but at the time, believe me, it would have been cool. So we put this course together, and basically what we did is we'd show a short video, then we'd ask a question, and the user would give an answer, and then we'd branch one way or another, depending on if they got the right answer or try to correct it some way. And then mostly they went back to the next one. And what we tried to do is use reinforcement learning to say, we've got this branch point where we can make a choice. What choice should we make? What should we do if we want you to get the next question right? And we found that by using that machine learning AI, we could make things better, but only by about 10%. So to some degree, we were kind of disappointed. We were hoping for bigger improvements than that, but we can only go so far. So that was 2011, but this is 2025, and maybe we can do something better now. And now we sort of have this goal of saying every learner should have a tutor who's maybe not quite as good as Socrates, but should be close. And every teacher should have a teaching assistant so that they're more effective and they could form closer bonds with their students. So that's the goal. And for the first time, just in the last few years, we have these AI models that maybe have the capability to do that in a way that the AI models of 2011 could not do them. Okay, so one possibility is this massive online class where it's basically me as the author of the class is in charge. I'm telling you, here's the path you should take, and then there's a few little branch points depending on if you got the right answer or not, but mostly I'm like 90% in charge. And then we have a chatbot where there's a completely empty box and you can ask anything you want. So the user is 100% in charge. And I think both of those are wrong. I think what we really want for education is something in the middle. If it's just a chatbot, you can ask anything, but you don't know what to ask. We really want the expert to say, here's a path you can go along, but not everybody's going to take the same path because everybody has a different background, everybody has different interests. So within this expertise of the teacher, the student is going to find their path. And that's what I think we have the opportunity to put together, and the AI models of today are the first tool that's capable of doing that. And we see some examples that are steps in that direction. They haven't nailed it completely yet, but they're getting close. So this is Khanmigo from Khan Academy, and it's a language model that you can interact with to help get through their courses. And you can see on the right, the student says, can you just tell me the answer? And if it was a regular chatbot, it would just say, sure, here's the answer. But they've trained the system to say, I want to be pedagogical, not just answer the questions. And so instead of answering, it says, well, it's important for you to do the work. So I wanted to quote some of my favorite mentors and experts. I got a chance to meet Herb Simon, one of the founders of AI, Nobel Prize winner. And this really struck with me. He says, learning results from what the student does and thinks, and only from what the student does and thinks. The teacher can advance learning only by influencing the student to learn. And this really struck me as, you know, say I was sitting down and writing a 1,000-page textbook. I'm saying, me writing that book does nothing. It's only if the student engages with that book that it's effective. And I've tried to always remember that. Benjamin Bloom said creativity follows mastery. So mastery of skills is the first priority for young talent. And I think too much in our regular education system, we ignore that. We say, okay, some students are going to master it and they're going to get an A on the test, and that's great and we'll celebrate that. But if a student gets a B or a C, we say, too bad, next week we're going to start a different topic. And that's wrong. We know that's wrong. Educational research says we've got to bring that student up to speed and wait until they master it. And so different students are going to be going at different speeds, really hard to manage in a classroom, but for the first time possible to manage with AI tutors. And finally, Theodore Roosevelt said, nobody cares how much you know until they know how much you care. So really this bond between teacher and student is crucial to learning. And that's where I think we've got to keep the human teacher in the loop. To some extent, people can form bonds with the machine and think that the machine cares, but the human is always going to be better at that. And at Google, we've released this module called LearnLM, which is a Gemini model, but fine-tuned for pedagogy. And these are the learning principles we have to inspire active learning. So as Herb Simon was saying, help the learner do something. Don't just tell them, allow them to do something. Manage the cognitive load. How much do they know? How much is new? Don't dump too much new stuff on them and understand where they are and what comes next. Deepen the metacognition. Help them learn how to learn. Help them understand where they are and why they're thinking about this. Stimulate curiosity. So that's hard to do, but try to make it exciting in some way. Try to make them think this is worth doing. And then adapt to the learner. Every learner is different. They have different prerequisites, different backgrounds that they have, different interests, and we want to customize to each learner. Another Google product is Learn Your Way, which is reimagining textbooks for every learner. So you put a textbook or a PDF in and you say, now generate it this way or that way. Make it into a podcast, make it into a video, summarize it, and so on. And I think this is really important because, I said it's not just good enough to have an empty search box from a chatbot and do anything you want. We really want the student to have the feeling of interacting with an expert teacher or mentor, but it's going to be a lot of work for the teacher to say, I have to generate 100 different versions of my work for every possible type of learner. So I think coming up with these tools that help the author is just as important as coming up with tools that help the learner. And there's been less focus on that in the past. So I'm really excited that we're starting to see this focus on saying, how can we help authors do a better job of authoring material that meets the users, meets the learners where they are. Now, where does data come from? And there's two possibilities. You get data from the real world or you get it from simulation. Now, I've done some work helping out with self-driving cars, And we have this motto that says, the first 1,000,000 miles are always the hardest. So what do I mean by that? Well, at first, you got to get those cars out there on the road, and you got to drive 1,000,000 miles, and you got to record all the data and figure out all the places where you went wrong. But after you do that, you can start building a simulation. And then in the simulation, you can drive billions of miles. And you can do that so much faster than actually driving on the real road. So that's how self-driving cars advance. So far, we haven't been able to do that for teaching. We don't have a simulation of a student. Students are much more predictable than, or unpredictable than traffic on the road. So we can only train with live data. And as I said at the beginning, that's useful. It's useful to collect that data. And if I want you to answer this next question right, I can make you 10% better at answering it. But if I want you to be a productive and happy student a year from now, it takes me a year to gather that data. And I can't move any faster than that. If I had a simulation, I could move faster. So that's been troubling. I've been worrying about that for years. But just in the past 2 years or so, there's these hints that maybe it's possible. So this is John Horton, an economist at MIT, and he tells these language models to simulate sort of economic experiments. Do you want to buy this? Do you want to trade this for that? And he kind of gives them a persona and asks them to act in that environment, and he finds out that they're actually pretty good simulations for these economic experiments. So the LLMs are able in some way to model what an actual human being is doing. Now, we don't know yet if that's going to go all the way to helping a learner learn a complex subject, but it is a hint that it is possible. And if it does become possible, then we start going like 100 times faster than we could before. So I'm really excited about that, but we're not quite there yet. Okay, so we're left with these big questions of what even is education, right? So I said, I can make it 10% better. I wish I could make it 50% better, but what even is it? And what is it that we're trying to make better? What's our goal? So part of education is teaching general knowledge. Maybe that's becoming less important as it's becoming easier to look up knowledge. Also, specific knowledge or skills for a profession. How much of that is part of your general education and how much maybe should be separated from that or into a trade school or something? Developing good reasoning and judgment. It seems like that's always going to be important. It's becoming even more and more important. Motivating and inspiring students to want to learn more and keep doing it is a key part of it. And then just this whole idea of promoting civic and social coherence. So part of being in school is not just the subjects you learn. Part of being in school is learning to get along with your classmates and learning what they're like and how some people are different from you and how you can get along with them. Then the next question is what is this for? I've been focusing on college level education because that's what I've taught. How much of that transfers immediately into K-12 education? How much of it has to be modified for that? And what about lifelong education? So, in this changing world, it seems silly that we have this idea that you go to school for 4 years, you get a piece of paper that says, I never have to learn anything again. Instead, we should be learning lifelong. And AI is an important tool for that, but we got to figure out what is it a tool for? What is it that we're trying to achieve? And that's the ultimate question. So why don't I stop there, and we got a couple minutes left if there are questions. Go ahead. Is there a mic or just yell?
I have a very interesting question. Personally, I'm a student at university, and it's concerned only about education and mostly about education programs. When I was in high school, I was learning complicated physics, chemistry, and all that general knowledge things, and I was thinking that I don't need it. And a lot of students often think in that way that they don't need to know complicated formulas or they don't need to know complicated mathematics, and even they want to be like, I don't know, maybe programmers. But right now I am a software engineer and I'm also interested in different things, and I'm started working on different projects, and finally I'm started interested in everything, and I started realizing that I need everything to know. young, when I was in high school, and
Yeah. Yeah.
when I was in high school, I just didn't realize that I actually need that. But and I have a main question: how teachers can influence or give like seat to students.
Okay, that's a good question. I think what we should be doing, you know, I said one of the points here is students learn by doing. I think we should focus more on having them do something, because that's just more motivating, right? So as you say, if you're taught in high school, we're going to take a whole year and we're going to learn this hard math subject, some people will be excited by that, but most won't. So I think a better approach is say, we're going to go out and we're going to do something. You know, we're going to teach you how to build a radio or do something. And then the students get started, and at some point they say, well, now I'm stuck. And then the teacher comes in and says, oh, this thing you're trying to do, that's called the differential equation. Let's think about that, and let's solve it in the context of this problem you're doing. And then students will be more motivated. They say, oh, if I learn how to do this, I can solve this problem, and I can move ahead, and I can finish what I'm doing. And I think that's better than saying you study for a year before you ever start to do anything real. So hopefully that's one good approach. Yeah.
Hi, thank you for the presentation. I have a question on school students, not the higher education, but I think it's generally can be applied for the higher education as well. So we have the STEM subjects and the more like humanitarian. I don't know, they are classified like HISS, HAAS. So do you think there should be like different approaches, you know, based on this classification? How do we apply AI in the school education? Or maybe there is like no differentiation between them when we speak about AI in education. Thanks.
I'm not sure I got the whole question, but I think it is really interesting to say how does AI interact with other fields. And I've worked with the data science program at Berkeley where they said we're going to have some core data science and AI, and then we're going to have lots of classes across all the different departments. So some in biology, some in astronomy, whatever. And there's a basic core, and then you're going off and you're doing the different domains and subject matters. Is that what you were asking, or did I miss the question?
Yes, I think yes, because why am I asking this question? Because the STEM subjects, like they are more, you know, accurate, like 2 + 2 is equal 4, like, you know. But when we speak about humanitarian, especially like arts, when we have art classes in school, how do we apply this kind of AI approach in those classes? And I believe there should be some kind of classification on that, or maybe a differentiation, or we can be speaking like, you know, on the fundamental thing, like the same approach.
No, that's certainly true, right? So, you know, if I ask you to make a painting or write a poem, there's not a right or wrong answer. It's a matter of judgment. I think the AI systems do have some capability to do judgment, so it won't be completely different. But you're right, it's not the same as saying, did you get the right answer or not?
Thank you.
Okay.
Hello, I would like to ask, I think, more of a technical question, if that's fine. You said that it would be interesting to use LLMs as kind of homo silicus, and I'm wondering now, in order to get a better simulation, you would really need to get the type of data that really reflects the real world distribution of the data, right? But the data that we use to train LLMs, it's mostly from the internet, and a lot of human communication doesn't really get captured on the internet. And even if something is in text, it could be not really available because it's private texts. So is there a way to make sure that what we use actually reflects real world?
Yeah, that's a great question. I think I agree with you, and I think we will have to gather specialized data to do this. It's not enough to just try to find it all on the internet. Also, I think you have to make a special effort to make models of student misconceptions, right? So a lot of what's written down is the stuff that's right? So, I write a textbook and I try to say, here's the right way to think about it. Now, in my experience as a teacher, I also know wrong ways to think about it. I also know, this student asked this question, they must have this misconception, which I know about, but I never wrote it down. And so I think we need to do a better job of writing that down. And there are places, I haven't done it much, but other people have done that. There are sort of repositories of questions and answers and wrong answers and explanations for why the wrong answers are there. And I think we'll need to harvest that. I think you also touched on some other things of if we had sort of bio data and permissions to collect that, sort of understanding what's your bio response, are you feeling nervous or worried and so on. I think that could be important, both to understand where the student is and to figure out, well, how do we comfort them, how do we inspire them to keep going, what's their sort of mental state as well as their correct or incorrect conception of the problem. Well, whoever has the mic should speak. I don't have to choose. Whoever has the mic, go. Yeah.
With microphone or without?
Yeah, with the microphone.
Okay. Thanks, Peter, for the amazing talk. And I do have a question a little bit about information retrieval, IR, because you have plenty of work experience in IR. And so the question is basically, currently the hot topic in IR is about powered AI search, basically RAG systems using, because I'm working in search, we are building enterprise search engines in UK-based companies. So how would you handle this hallucination from LLMs, for example, because sometimes you can get a lot of unpredictable response, and especially in search.
Yeah. So it's certainly true if you have a naked LLM, it's going to hallucinate every now and then. And it's kind of designed to do that for a couple reasons. One is they're also designed to be creative, right? So you can say, make up a poem about any subject, and it will generate something that's hallucinated because it was never written down before. I think we could do a better job of saying, now your job is to be creative. Now your job is to say something that's backed up by facts. So I think we can do that, and we should build it into the models, and then we should also have checkers on top of that, RAG-like systems and other systems that say, I went out to the LLM, I got an answer, now I want to verify that answer before I expose it to the user. Then the other thing I think is we're doing the training wrong. So a lot of the training we do with both in the self-supervised training and in the reinforcement learning with human feedback is saying either you got it right or you got it wrong. And if you do that, and you guys who have taken tests know this, right? If you're being graded just by the number of things you get right, if you don't know, you should guess. That's the best strategy for optimizing your score. I think we should change the scoring metric to say, if you guess and you're wrong, that should be 2 points off. And if you instead say, I don't know, well, you should get 1 point for that. And that should be almost as good as giving the right answer. And so if we changed our scoring metric, we can really cut down on hallucinations. Who's got the mic? Yeah.
Thank you for your
let
speech.
this guy have it next. Yeah. Go ahead.
I used to study from your textbooks about AI, and now different approach win, maybe. And what is your vision? What is the true path to the AGI?
I don't like the term AGI because I don't think of it as an endpoint.
I mean, AI that can learn from, by observing
Yeah. So I think a bunch of things. I think embedding in the world is important, right? So it's been amazing to me how much we can learn just by reading text, right? So, I've been in this field for a while. In the 80s, I started doing natural language understanding, and I said, there's some stuff that's on the page of the book, and we had to do some linguistics and so on to understand that. But at the time, we thought more of what's going on is up here in the head. And we thought the hard part is going to be figuring out what's in the head as you process that text. And then LLMs came along and said, we'll just put an absolutely flat prior into the head that knows basically nothing, and then we'll just pass a lot of words through it, and that worked. So I think that amazed everybody. We didn't expect that. But you know, there's lots of things we can do to make it better. One of them is going beyond just the words and experience life in the real world. And I think we're starting to see the rise of robotics. It's always, robotics is coming in the next decade, and that's been true for 3 or 4 decades, but it's getting better. And living in the world, I think, is important, and you will learn more that isn't in the text. And being more explicit about creating world models rather than word models, right? So a language model says, as you're speaking a sentence, what word is likely to come next. In order to come up with the right word, you have to understand something about the world, but you're not explicitly modeling the world. Instead, you're just modeling how do we talk about the world. And these world models based on multimedia perception and on robotics and living in the world, they say, well, I'm actually going to model what's happening in the world, and then secondarily I can talk about it. So I think that'll be a good step. And then I think kind of natural growth will get us there, right? So we've seen this huge advance in the amount of data, in the amount of processing power, and a little bit in coming up with clever algorithms. And if that continues, we'll get closer and closer to acceptable intelligence. I don't know if I want to call it AGI, but it will get better.